Right, so what we're going to do today is we've got a lecture on acid base, and we won't get to the buffer part, but we'll do the acid base. We're going to talk about solubility, and when you picked up a titration of beverages, we're going to do that next time. I'm just going to slide up and sort of explain the rest of it. So we'll do the titration of beverages. Then we won't quite make it through the lecture today, so we'll finish the lecture on next Thursday. You'll get the pre-lab buffer, but your lab notebook will be due that day. So you'll have 3 labs in it. You'll have your pH home lab, your titration, and your titration of beverages in there. Okay? We'll do the buffer lab first of 4th term, and that will go into 4th term. And then you've got a work day, and your test is open from the 21st to the 28th. Okay? So that's sort of what's going down. Let's take just a second and look at your lab for a minute for next time. This is the acidity of beverages lab. We're going to be working with pineapple juice, apple juice, and grape juice. So the grape juice will have tartric acid in it. How many of you have parents that can grape juice at home? Anybody? Okay, have you ever poured out the thing and down at the bottom there's crystals? That's tartric acid crystals. So that we'll be looking at the acid there. The pineapple juice will be looking at citric acid, and the apple juice will be looking at malic acid. And we're going to do titrations just like we did last time, where we do a fast one to see about how much we need to slow down at. Then we're going to do one where we do the titration curve, come print it off. While one person's printing it off, the other one do a quick titration and of the next one to see where you need to do, get it set up. They'll come back. You do the long titration of that one, then switch places. That person goes, does the next, or does the printout of the lab, and the next one does a quick dump for the next one, gets it set up, and then you come back and do your last one. So you're going to be doing a total of 6 titrations next time. 3 quick dumps and 3 longer ones. So by the end of this one, you should have titrations down. Okay? So having said that, we're actually going to also do in this lab a place where we take and we have test tubes full of acid. And I'll give you each a specific indicator to do. And you're going to be testing, you've got pre-lab questions here. You've got your titration curve, what it should look like there. But you'll be testing your indicator to see when does it change. At what pH does it change. And so all you're doing is setting up test tubes with different amounts of acid in it. So it's at different pHs. And then you'll put the name of the indicator, what was its initial color, what was its final color, and the change in milliliters of NaOH. Now you'll notice on here, this is like that rate law lab, you get to write up the procedure. So we've done a titration, right, where it's quick. So you're going to have to do a quick titration and one that uses the pH probe for each acid. For the pineapple juice, for the apple juice, for the grape juice. I can't remember what the last one was. Okay, so you need to write me up a procedure. Think about how we did last time, what you need to do, how you're going to approach it, but that needs to be done. Okay, and that is what we're doing next time. I gave you a blank table that you can set up to decide how much you want of each. You probably don't want to use more than 2 milliliters of your juice. Okay, so don't use more than 2. It'll take you forever if you do. Then you've got some stuff where you're going to analyze what the difference was between them, and you're going to attach your 3 graphs that you'll make. Okay? And you can use a snippet tool if you want to and make a Word document as you come in and you get your graph pretty rather than print it each time. Use a snippet. Snip it onto a Word document so you can get all 3 on a page so you can save paper. That's awesome. Okay, so go ahead and do that. Questions? Yes?
So on the first graph table, you talked about the indicator.
So whatever indicators I have out, that's what you're going to use. Okay? So if we look at the procedure right here, you're going to label 5 test tubes, 1, 2, 3, 4, 5. And write down in the data table which indicators you're testing. So I'll have a bunch of different indicators to do one at a time. Using a 10 milliliter graduated cylinder, you're going to pour in 2 milliliters of acetic acid. Then you're going to take 1 or 2 drops of indicator into each test tube. You're going to record the initial and go from there. There should be a point where you should be taking 10 milliliters. Just take 1 milliliter from that, put it in the next one, add 9 drops of distilled water. I must have missed that in doing the thing. So we need to make sure that it's making a dilution. So you start with the strong acid, and then you take one of those and put in the next one with 9 drops of water. 1 drop of that in the next one, 9 drops of water. 1 drop of that in the next one, 9 drops of water. Until you have 5 test tubes. And then you just put the indicator 1 or 2 drops in each, see what the colors do. Dump it out, do it again. Okay, not hard. Actually, I think, let's see. Oh, you are going to be adding NaOH, so you can see how long it takes to change. Same kind of thing that I did with the dissolution that I was just talking about. But look over that, and we'll go with that next time. So you're going to have the 6 titrations. Again, we went pretty fast last time, and it was your first titration. As you get going on these, they'll go faster and faster and faster, and you'll be good. Okay, so we're going to start with your notes from last time. We're going to start right after the first set of notes in the notes. Does that make sense? The first set of notes in the notes. So when we skipped ahead, so we're going to, I think it's 9.4. Okay, we're going to start there. Don't forget about your home pH lab. The stuff we're going to learn today helps you finish that home pH lab. And then you'll just have those 3 labs that are coming in. Okay? All right, so first up is water can self-ionize. So this up here is showing the Lewis dot for water self-ionizing. So that asks you down at the bottom to write that equation out and show the Lewis dot. So go ahead at the bottom of that page and do that. When it means neutral, all that means is my OH concentration is equal to my H plus concentration. That's neutral. Okay? So you'll notice here, I've got one water drawn in red and the other water drawn in blue. The red being the acid one and the blue being the base one. And you can sort of see that one of the red H's goes over to the blue acid, or blue base, and makes it an acid. And on the other side, the conjugate acid is H3O plus to the base H2O. If you go on the other side of the acid, and I probably should have put over here conjugate so you knew. It's not going to let me write. Okay, this is fun. Okay, I'm going to pause that really quick and I'm going to bring it. Oh, that's good. All right, so has everybody got that written down? We're going to go forward here. With water self-ionizing, we have an equation that we need to learn. And that is, this is the self-ionization without the Lewis dot. Now, if we were doing a K of this, remember liquids and solids and gases, liquids and solids drop out. Gases and aqueous stay in. So the left-hand side here would drop out, and all I would be left with, whoops, went too far, is this. So the Kw of water is just the hydronium ion times the hydroxide ion equals 10 to the minus 14. At distilled water, we get 10 to the minus 7 equals 10 to the minus 7. That is our hydronium and our hydroxide concentrations. Okay? So this bottom equation we're going to use on the next page. So make sure you've got it written down. And we're going to go on to this next one. So you do need a calculator out. You do need a calculator out. If you don't have a calculator, come get one out of my sink. We're going to be using it quite a bit today.
But like I didn't get an answer. I just guessed.
So it's PV equals nRT. Did you remember the R? 821, yeah. Okay, so let's sort of look at this. I believe this next part is down a little bit on this. You guys help me? Yes. So, and we'll come back to acidic solution and basic solution. Basically, acidic solution is just more hydrogens than hydroxide concentration, and basic is more hydroxide than hydrogen concentration. So when you have an acidic solution, you have more hydrogen. When you have a basic solution, you have more hydroxide. That's it. Okay, so on these, all you have to do to solve for the hydrogen is just rearrange the equation. So you get 10 to the minus 14 divided by parentheses 1.0 times 10 to the minus 7. Now, do I need to put the 1.0 in? No. If it's something other than 1.0, I do. So go ahead and put that in your calculator, and what do we get for an answer?
Zero, 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 zero.
10 to the minus 7 is what you should have got. So 0.6 zeros and a 1. Okay, so let's do the next one. So this is my hydrogen concentration, H3O plus. You'll see me write it that way, and I also shortcutted when we were in college, and we wrote it just like this. Either means the same. Hydronium ion is just with water attached to it. Okay, so let's do the next one. We have 10 to the minus 14 divided by parentheses 3.8 times 10 to the minus 2. What do we get on this one? And I just am rearranging that equation that we had, which was Kw, which equals 10 to the minus 14, is equal to the concentration of hydroxide times the concentration of hydronium. So if I have one of them, I can figure out the other. Okay? So what do we get for this one? Times 10 to the... Okay, all of these should be concentration M and molarity. I didn't put it in there, but they should be all concentration M, molarity. I'm going to let you do the next 4. I'm going to pull people from the class to put them up. So I'll let you sweat it here for a minute before I decide who gets to come up. Okay, let's see if thumbs down. Good. Number 5, thumbs up or thumbs down. And number 6, thumbs up or thumbs down. Uh-oh. We got a couple thumbs down there. Yes. Yeah, they should all have molarity. Yeah, they should all have molarity. Okay, so this one is actually, I did it with him, so it is actually right. So those of you that had thumbs down might want to recheck it. Okay, let's go ahead and go forward. What I'd like you to do now is do the same equation you're finding concentration of hydroxide now. And I'm going to pull 4 people to put those up. So quickly do those. So it's still the 10 to the minus 14 divided by, put the bottom in parentheses.
Right.
Yeah, you should be writing M. I haven't been doing that up there, but you should. Okay, let's have Kylene do number 1. Kate and Schroeder do number 2. Landon's not here. Cameron, do number 3. And Isaac, do number 4. Should be able to write 2 of you at the same time. I don't remember. Okay, that works. Okay, we're going to do thumbs up, thumbs down again. They should have molarity with them still. So on number 1, did you get 2.9 times 10 to the minus 12? Thumbs up or thumbs down? Okay, good. What about number 2? Thumbs up or thumbs down? Okay, number 3. Ooh, I see a couple thumbs down. We might want to check that one. Number 4. Okay, mostly thumbs up. So the only one I saw was a question mark on this one. Most of you are thumbs up, but we had 1 or 2 thumbs down. So those of you with thumbs down, double check it. Okay, going forward. We're going to be going into the pH scale. You got pH paper last time, or time before last, to do a pH home lab. So now we're going to talk about it. If you have a pH of 7, it's neutral, meaning you have the same amount of hydrogen concentration as you do hydroxide. If it's a pH less than 7, it's considered to be acidic. That's the red part of your pH paper. If it's greater than 7, it's considered to be basic, and that's the blue side of your pH paper. So as we do this, you can sort of see it's sort of a rainbow starting here and going up. About 7, you get a light green, sort of a lime green, and then it goes into a dark violet over here. And red, of course, comes down here. Now, it's said to be 0 to 14 as far as the pH scale. But if we have a really, really, really strong acid or a really, really strong base, we can get up to a negative 2 or 3 and up to 16 as far as the pH scale goes. So the acid that I get from the distributors, which is an 18 molar sulfuric acid or 12 molar hydrochloric acid, will be negative. If I get the really strong bases of sodium hydroxide or potassium hydroxide are really strong bases, they will also be up at around 15, 16. Okay, so know that. We're going to go P, by the way, anytime you see P, it's going to mean minus the log. So just to give you some ideas, if you haven't started this lab needs to be done next week. By Thursday, we're handing in those 3 labs next week, so make sure you get it done. Some things you could test: battery acid, lemon juice, vinegar, and you can see right here, this is what we consider the acid range area. Normal range of rain would be between 5 and 6.5, and that's because there is carbon dioxide in the air, there are some pollutants in the air, and so as it comes down and it grabs the particulates that are in the air, we do get some change in pH, even with really clean air. We've got milk here that's a little bit acidic, and then we go to baking soda, which is on the base side, seawater, milk and magnesia, or Tums, ammonia, and lye. So you can sort of see what's going on here. Here's a different scale that goes side to side, but same thing. Gives you some ideas of some things that you could test and about where they should be. So if you look at Coke, it's 2.6 compared to battery acid of 1. So that's why Coke does really well at cleaning off grease from driveways. It works really well for cleaning off grease of metals and everything else. So some things we consider there. So some important equations that we need to worry about. The first one we've worked with is the Kw, which is equal to 10 to the minus 14. You do need to know that. There's a few others that we need to worry about. pH and POH. Anytime you see P, it's going to mean minus the log base 10 of hydronium ion or the hydroxide ion. If you're using my calculators, you actually have to push the button that says ln or log twice on the solar ones to get to log. Okay, so just know that, and it's minus the log. If I'm trying to figure out pH or pH from each other, these two add to 14. And if you'll notice, 14 is what the exponent was up here on the kW. If I'm trying to get to concentration, I just take 10 to the minus POH or 10 to the minus pH to get there. Now, I know you're all furiously writing this down. You'll get mad at me, but that's okay. I've got a handout for you that has this all on it. Okay. This is my little pH square that I really enjoy and love. It helps me go from one equation to another. If it were me, this is something that I would copy onto my 3x5 card. So I had it on my 3x5 card because it helps me get all the way around everything that I need to do. Remembering that H plus is the same as H3O plus, I just couldn't fit it in there. Okay. As we go around, we're going to look at some really pretty things here. The red side is going to be your pH, and the POH is going to be your blue side. So if you look at this, you can sort of see what's going on. I tried to color code the arrows and that. I didn't work on this, but you can follow the arrows which way you're going and where you need to go. Okay, so let's try some of this. So we need to be able to just look at a pH and be able to tell me, oh, it's acidic or basic, really fast. Okay, number 1, neutral. Number 2, acidic. Number 3, number 4. Good. So acidic and basic for the last 2. Be careful on the test. She will put POH on there, and you need to subtract that from 14 in order to get the pH then to determine. So watch that, okay? Make sure you understand what's been given. So when we use the pH equation, we've got minus the log of the hydrogen concentration. Remember, brackets mean molarity, okay? So these are not on your thing right now. We're just going to do a couple, and then we'll go into the ones that you've got there. So we're just in practice. So on your calculators, really quick, just go minus the log of 10 to the minus 10. We don't have to put the 1 there. Just practice it. Minus the log of 10 to the minus 10. Huh? Minus. I mean, sorry, it's just the negative down there at the bottom of the, yeah. Okay? It should be 10. Did you get 10? You got 10, you got it. Okay, now, try this one. This one's a little bit different. You got to put the whole thing in. So minus the log of parentheses 1.8 times 10 to the minus 5. Okay, let's see if you got this answer. Okay, now here's the trick. Here's the way that you check yourself. This number right here should be close to this number. If it's not, you did something screwy, redo it. Okay, so on the test, that's your quick check. Okay? All right, now, next thing. Here we have been given one thing on your square. We've been given pH. Put your finger where pH is. We need to find every single thing else, every other square, every other corner on that block. Now, I'm going to give you a little hint that I do, because I always screw up when I go across the bottom from H plus to OH minus. So I always go up and around and avoid that one, because then I forget to put the parentheses on the bottom, and then I end up with a funky answer. Okay, so if we do this, say pH, I can take, pH of the solution is an acid, so I now need to be thinking acid. I can take that number away from 14, and I've got the POH going straight across. Follow it? Okay. Now, I've got these two numbers. Put your finger on one on each one of them. I can go straight down from each of those to get to H plus and OH minus. And what do I do when I do that? 10 to the minus pH, 10 to the minus POH. But I can't just write this. I've actually got to put it in my calculator and get this. Okay, does that make sense? So then I do the same thing for the OH. Again, I can't just leave it 10 to the minus 9.5. I can't have an exponent that is a point something. I've actually got to have a whole number to make it right. Okay, so now I've walked you through this one. I want you to somewhere on your paper, it doesn't matter where, you can go back the page before if there's some space. I want you to do this one. So put your finger on what I gave you. Okay, now you got to get to the rest of them on there. Go. I'm going to give you about 5 minutes. Nah, 2 minutes. Yeah, just write it somewhere. Maybe the page before you had an empty blank space that you could use. Like up at the top where there's basic acidic, where we didn't really write anything. So just write down each of them. What is the pH? What's the pOH? What's the concentration of hydrogen or hydronium? Let's see if you did it right. Okay, about another 30 seconds. Okay, let's see how you did. Go ahead and check your answers with what's on the board. How many got them all right? Okay, the funny thing is with pH, you always want to report to 2 after the decimal. The number in front of the decimal is not considered significant. So always report to 2 after the decimal. 3 after the, you don't want to do 3 after this. It's just pH is reported to 2 after the decimal, done. Okay. We ended up with a pH of 6.73, which is barely acidic, almost neutral. So we need to be able to rely on that. Now I only saw 2 or 3 thumbs or hands. How many actually got these right? Okay, much better. I was like, if not, we need to stop and go over this again. Okay, so we're going to try this. I have given you different things, and I want you to find the pH. You can go either way, any way you want to go. I'm going to pull people to put this up. These should be at the front or the next page, top of the next page. Okay, I'm hoping. Is it not? It's the one under it. Sorry. Okay. So 9, 10, 11, but I'm doing 1, 2, 3. So if you get ahead of me, great. Keep going. I'm going to pull some people to come and put these up on the board. I just want you to find out what the pH is and then tell me if it's acid, base, or neutral. Okay, so find the pH, write the pH down, and then tell me acid, base, or neutral. Let's see. Zach, I'm going to have you put up number 1. Larissa, I'm going to have you put up number 2 on mine. And Bryn, I'm going to have you put up number 3. Mm-hmm.
Is it both of them? Like both of them times each other?
Mm-hmm.
So
if you want one or the other, you're going to take 10 to the minus 14 divided by what you're given.
okay, so
In parentheses.
so like if you don't even like if I'm trying to find the H plus in this case.
Then you take that divided by the OH.
Oh, okay. So you don't really need the other one to find it? I thought like 10 to the negative 7 equals that.
No, because those two times together equal 10 to the
Oh,
negative
I thought you
14.
take 14 to find the other one.
Right.
Mine is the pH, so it would be minus log.
Minus log of that, and that'll give you the pH.
So,
And it should be close to 9, which it is. So you're good. And that would be what? Acid or base?
base.
So go ahead and put that up. Okay, how many agree with number 1? Thumbs up or thumbs down? Awesome. Number 2. And number 3. With the exception, it should only be 2 after the decimal, right? Okay. All right, going forward then. So we're going to do a learning check. Okay, you had some others there that you can do, so you can practice. But we're going to stop and do a learning check. So somewhere, again, you can grab a piece of scratch paper or whatever. I want you to take a pH of 8.3 and find everything else on the period on that square. And then tell me if it's an acid, base, or neutral situation. So everybody try it. Okay, how do we do? Let's see how we did. Whoops. Okay, thumbs up. Did you get the POH? Thumbs up. Did you get the hydronium concentration? How many got the hydroxide? Right. And how many got that it was a base? Okay, awesome. Okay, so let's go forward. We have some properties of acids that we need to talk about. When we talk about a general reaction for acids, it's just meaning it's going to give off an H+. Okay, our dilution equation is C1V1 equals C2V2 or M1V1 equals M2V2. It's the same. Remember, C just stands for concentration. I can also set it up as MAVA, molarity of acid times times volume of acid equals molarity of base times volume of base for a titration. So we use this equation a lot. The problem is we can only use it for acid and base titrations if the acid and base are a one-to-one relationship, meaning one hydrogen to one hydroxide. So if I have H2SO4, I can't use it. I've actually got to times the molarity times the liters, get the moles, write the equation, go from moles to moles, and then go back to molarity. Okay, so there's more steps. So on this one right here, just to prepare, we're just going to use a C1V1 equals C2V2. So we would actually go through and our concentration 0.500 molar times 750 milliliters divided by 6.00 molar. Molarity would cancel and we'd be left with milliliters. So let's do that, find out how many milliliters we would need. 62.5 milliliters of H2, the 6.0 molar H2SO4. Okay, so it wants to know how I would make that. So the first thing I would do would be get a volumetric flask that had 750.00 milliliters. I would fill that 3/4 full. So number 1, number 2, with distilled water. Then number 3, I would add this in. And then number 4, you like my little diagram here, I would swirl it so it mixed really well. And number 5, I actually want to make sure that I fill with distilled water till the meniscus is right at that line. So we did that last time, except we worked with pellets, right? We made our 0.1 molar solution. Okay, we're going to be doing that again for the next lab probably because we won't have enough. We'll see how far we go. Any questions with this? So when I say explain, you can use diagrams like I do, or you can use words. It's up to you. All right, so going forward here, and I forgot I'd already had that written down underneath, so we're just going to go on. How many remember this video with solubility tricks? Okay, what was the name of that video? Do you remember? What was the thing to help you remember what things were soluble? NAG-SAG. So NAG means what? Nitrates, acetates, group 1 metals. SAG means sulfates, ammonia, and group 17 metals. There were some exceptions to the rules. What were they? Castrobear, what did that go with? Calcium, strontium, barium attached to what is not soluble? Sulfates, good. And then there was a second one, PMS. Remember PMS? Lead, mercury, and silver. Attached to what? Attached to what? Do you guys remember? The chloride, the chlorine. So group 17. So if they're attached to group 17, they're going to be solids. We need to remember this when we're doing this because I'll put this video up if you don't remember it. I'm not going to take the time right now to go through it. Okay, but it will be up on your canvas. So we need to be able to write molecular equations, ionic equations, and net ionic equations when we're doing acid-base. So hydrochloric acid, what's the formula? Hydrochloric acid? HCl. Okay, HCl plus strontium hydroxide. This is one of our strong bases. SrOH2. Then we do OI, which is outsides and insides together. So outsides would be water, right? H and OH make water. Plus, I should leave some room in front of that so we can balance. The insides are going to go together. Strontium has a +2 charge. Chlorine has a -1, so we need 2 of them. This is not balanced. What do I need to do to balance it? Get 2 hydrochloric acids, right? And 2 waters. Good. Okay, so to do the net ionic equation, I got to think back, okay, this was a strong acid, right? HCl is one of our strong acids. So it's going to be a cute little ion. It'll split right up to its ions. This was a strong base, so it's also AQ. Water is always a liquid. What's strontium chloride? Is that one of our exceptions to the rule? Is that one of the things that's soluble? What is it? It's soluble because remember with chlorides it was PMS. So heavy metals with chloride. This strontium was with sulfate. So this is going to be AQ also. Anything that's AQ I can split into ions. Anything that's solid, liquid, and gas I have to leave as is. Okay, so my net ionic equation says, okay, split that up. That becomes 2H plus AQ plus 2Cl minus AQ plus, next one, strontium, Sr plus 2 AQ plus 2 OH minus AQ yields Sr, whoops, that's one on top of each other, plus 2 AQ plus 2 Cl minus AQ plus 2 waters that are liquid. Okay? So once I get it all into what is known as the ionic equation, I want to know which one are spectators. Spectator ions are the ones that stay the same from side to side. So which ones stayed exactly the same from side to side? Sr, strontium, good. Any others? Cl. Okay, was there any others? Okay, so these in the red, underlined in red, are known as our spectator ions. Spectator ions. Okay, these are ones that we can get rid of for the net ionic equation. So for the net ionic equation, as I come down here, I would write 2H plus AQ plus 2OH minus AQ yields 2H2O liquid. Okay, now, what do you notice about that equation? Yeah, we don't need the 2's because they'll all cancel out. It's like a math equation. If they're all the same on both sides, we get rid of them. So our final net ionic equation is just H plus AQ plus OH minus AQ yields H2O as a liquid. Everybody okay? All right. So we're going to go forward and we're going to try another one. The next one is calcium in cold water. What's calcium? Ca. It didn't say plus 2. It didn't say ion. So if it's not an ion, what are most metals? Solid, liquid, gas, aqueous. Metal, solid. Okay, plus cold water. H2O. Okay, yields. Okay, we know water splits up into H and OH, right? It doesn't split up H and O. So calcium will take what kind of charge? Where's it at? Positive 2. So it's going to take a positive 2. Is it going to go with the H or is it going to go with the OH? OH. So we're going to get over here calcium hydroxide because we'll need 2 hydroxides to go with the calcium. What is calcium hydroxide? It's a strong base, so it's going to be AQ, and I forgot to put the L next to the water. What else is left over that I need to have with? What got kicked out? Hydrogen, which is a Braunhifkel, which is a diatomic, so I put H2, and that's a gas, right? Okay, so the only thing that's AQ for my ionic equation is calcium hydroxide, right? So writing the ionic equation, I'm just going to go calcium solid plus water liquid yields calcium plus 2 AQ plus 2 OH minus AQ plus H2 as a gas. Is there anything is there any spectator ions in this? There are no spectator ions. So my ionic equation is actually also my net ionic equation. Yes, ma'am. Spectator is when I have the exact same thing side to side. So here, 2Cl minus and 2Cl minus were exactly the same side to side. Strontium plus 2, strontium plus 2, exactly the same side to side. So that's when they become spectator ions. Good question. Okay, any questions with this one? Yes? So that was our Tetris pattern that we learned about last time. So lithium hydroxide, strontium, or try that again. Lithium, sodium, and potassium hydroxide, slide over, calcium, strontium, and barium hydroxide. So LiNAK, C8, SrBa. So the second column over gets 2 hydroxides. Okay, so let's go to this next one. So if I need to make up a solution, and this is practicing, if I need to make up a solution of 200 milliliters of 0.1 molar, we did 250 of 0.1 molar last time. But this time I'm doing it from a stock solution. I need to dilute it. So I'm using C1V1 equals C2V2. Would you figure out how much you need? Zach, put it away. So you're just using C1V1 equals C2V2. Find me the volume. And then tell me how to prepare it. I did that with you earlier. Okay, what do we get for the volume? 3.55 milliliters. Okay, milliliters. So we're going to grab our volumetric flask. That's 200 milliliters, right? Then we're going to fill it. So 1, 2, fill it with distilled H2O, about 3/4 full, right? Then we're going to add this much of 5.7 molar stock. Whoops, I can spell stock really, I can. Into here. And then we're going to, for the fourth one, that was 3. For the fourth one, we're going to add distilled water to the meniscus. Okay? And swirl. And swirl. I should have put and swirl in between there. Yes. So 4 is my swirl. 5 is my distilled water. Good catch. Okay. Anybody have problems with that? We did that. We know how to do that. No big deal. Okay. I want you to try this one on your own. We just did 2 molecular ionic and net ionic equations. I want you to do this one on your own. Try it. See if you can do it. Nitric is one of our strong acids, our first one of the swoop. So nitric came from nitrate and hydrogen. Okay, do not look up until you are done. I'm going to start putting it up so we can look at it. Calcium oxide is actually chalk, so it's going to be a solid. Okay, calcium oxide is chalk, so it's going to be a solid. Also known as lime. How many got the molecular equation correct? Okay, if you haven't, go ahead and fix it and move on to the ionic. Yes, Matt, sir.
So why is it H2O instead of OH?
Okay, OH is what? Is that balanced? You still have a negative, you'd have to have a -1, and this one won't. So since we're doing a molecular equation, we want everything to balance out. So we have hydrogen and oxygen left over. Normally water's made with H and OH, but it can be made with H and O. Okay, good questions. Nope, it's H2O. And the reason I knew that the calcium nitrate was soluble, that's the first of our NAG-SAG. That's our nitrates are soluble. So that's why it was AQ. So in other words, you put chalk into nitric acid and it will dissolve and give you calcium nitrate and water. Okay, let's see how you did on the next part. How many were able to get the net ionic, or the ionic equation? Be brave, be brave. If you got it, raise your hand, be proud. Okay, we had a few. What are my spectator ions? Yes, sir. Yes, ma'am.
Wait, so why wouldn't you separate this CaO?
Because it's a solid. So I can't separate solids, liquids, or gases. Okay? All right, so what are my spectators? The nitrates are my spectators here and here, exactly the same. So these are spectators. Okay, and that's the only one, right? Just nitrates. So we rewrite the bottom here, 2H plus AQ plus CaO solid yields calcium plus 2AQ and water, H2O as a liquid. Okay? Ca is AQ and it's a Ca plus 2. Because any ion is a cute little ion. It's always AQ. Calcium oxide is a solid. Okay, we get this? Thumbs up, yes. Thumbs down, no. Thumbs sideways, eh, sort of. Okay, we got some thumbs sideways. Hopefully we'll get this more. Okay, so I actually went through and put those in. Oh, whoops. Okay, so let's try another one. Let's do this one. Hydrochloric acid and calcium carbonate. I'll give you a minute head start. Let's see if we can do this. Now, carbonates are not soluble, so that's going to be a solid. Calcium carbonate is a solid. That's what's usually left in your shower as hard water. Okay, you probably wouldn't know this, but carbonic acid quickly breaks down into water and carbon dioxide. So I'm stopping you there so you get that. So make sure your molecular equation is correct. So this carbonic acid is really not there. It's water and carbon dioxide. Okay, fix that. Go on to your ionic equation. Oh, make sure it's balanced because I don't think it was. No, it is. H plus is an ion. It's an acid. Okay, when you get the ionic equation, how many were able to do that fairly quickly? Yeah? Good. Okay, what's our spectators? Who are our spectators? Chlorine is a spectator. Good. Are there any others besides chlorine? There's not. So then you just rewrite it without the chlorine. So down here, 2H plus AQ plus CaCO3 solid yields water as a liquid plus CO2 as a gas plus calcium as an ion, and we're done. How many feel better about this now? I want a thumbs up, thumbs down, thumbs sideways. You getting this? We're still got a few thumbs sideways. Okay, let's keep going. Oh, and I forgot I put those all in. Okay, so we're actually going to go into properties of bases now. So bases have some unique properties. Come on, there we go. When a neutralization reaction, we've got a strong strong acid plus a strong base gives us salt and water. What type of reaction is that? Whose theory is that in? Arrhenius. Good. That's Arrhenius's theory when we get salt and water. So for instance, with nitric acid and sodium hydroxide, the molecular equation would be this. Right? Everybody okay with that? I want you to write the ionic and net ionic equation. I really want you to practice doing this. So we need to know which ones are soluble. Is there anything that's not AQ on this? H2O. Okay, go ahead, write your ionic equation, then your net ionic. So H2O is the only liquid, the rest are AQs. Remember to get rid of all your spectators or circle, identify your spectators, and then put them in as a net ionic. They should be written as H plus AQ, and NO minus AQ, and A plus AQ, and OH minus AQ. For those of you that are struggling, I put the ionic equation on the board. If you are not struggling but check it, make sure you've got that right, and then do the net ionic equation. Remember, circle your spectator ions. The things are exactly the same on both sides. Okay, how did we do? We doing okay? Do we understand this? I don't want to bulldoze you if you're not understanding. Speak up. You're in charge of your own education. Okay, we okay to go forward? Yes, no, maybe so. You guys that were sideways, are we getting this now a little better? Okay, so here's one again for yourself. See if you can write the molecular equation first, and then I'll show it to you to see if you got it right. And then do the net ionic equation and our ionic equation and the net ionic equation. Remember, you do have to balance it first. And then you got to decide which things are soluble. If it's a strong acid, it's going to be AQ. Strong base, it's going to be AQ. And then you got to use the solubility rules for the salts on the other side. Yes, ma'am. So 8, it came from 8. So it'll be SO4. SO4 has a -2 charge.
This like it gains one, which means that's an acid. Or
That's a
base,
base.
that's an acid.
That, yep.
So then, okay. So that's an acid because they gave one away.
This is a, you got them flipped. Yeah, so that's an acid, that's fine. No, that stayed on the acid side, but this is your acid over here, so that needs to go over there. So you got those two flipped. There you go.
Oh yeah, exactly.
Okay, how'd you do? Get that? How about your ionic equation? How many are finished with that? I don't want to rush you. Not yet? Okay, I'll give you a few more seconds. Try and do that ionic equation and the net ionic equation by yourself. You got to be able to do that. Okay, we're almost out of time, so I'm going to go ahead and put it up on the board. You should be able to do these, okay? So what the plan is next week we're going to do the titration of the beverages, the first day, Tuesday. Thursday, your lab notebook is due with the 3 labs, the titration, the pH home lab, and the beverage lab. On Thursday, I will give you the buffer lab that we'll do the first day of 4th term. Okay, that will go into your 4th term lab notebook, and you'll turn that in after I come back. Okay, yes?
Why is there 2 in front of the product cake?
Oh, I didn't put a 2 here. There should be a 2 here and here and here. So this 2 will go away, right? Because they would all have a 2 in front of them. Okay, good catch, guys. Awesome. Okay, we'll see you next time. Be ready for the titration or the beverage titration lab. Make sure you understand what's going on. Do your pre-lab. Be ready to go.
So for the net ionic equation, it's basically just taking out the spectator.
Yep. Yep.